is what we're covering today, tomorrow, and probably Friday, is solving. We're going to be solving rational equations. Now, the first ones that we're going to solve here are these here. 3 over x plus 1 is equal to 9 over 4x plus 5. No. Now, we're going to solve these using the least common denominator. We're going to multiply, and we want to reduce these fractions. Now, we're going to use multiplication to reduce these fractions. Now, what would I multiply the 9 over 4x plus 5 by to get the fraction to reduce or to simplify out? What could I multiply this by? We can use 9, but because if I multiply it by its denominator, the fraction would simplify, yes? So what would we multiply 3 over x plus 1 by, 3 over x plus 1 by, so that its fraction reduces? Well, right, but we can't just multiply one side. I mean, I have to multiply on both.
Do we have to multiply the numerator and the denominator? Like put it on the addition or just
Numerator. Now, the reason we did that on the other ones, the complex fractions, is because we're just dealing with a fraction. So we're multiplying the whole thing by 1. Here, we actually have equality. So in all the ones leading up to this point, we were talking about expressions. We didn't have things that were equal. So here, because of equality, we can multiply it across the whole thing. And that's kind of the main difference. And the way that this works out, and the way that it actually is kind of nice, is the 4x plus 5 and 4x plus 5 simplifies here. The x plus 1 and x plus 1 will simplify. And let's see what we have left. Well, on the left-hand side, I have 3 times 4x plus 5 equals 9 times x plus 1. Try that again. X plus 1. So when I look at the left side of this here, well, the x plus 1 and x plus 1 canceled out, yes? So is x plus 1 completely gone from this equation? Well, no, where is it at? It's on the other side, yes? On the left-hand side, the 4x plus 5 and the 4x plus 5 here simplified out. Well, it's not gone completely. It's now on the other side. So we still have those terms. They're just on the other side. They're still there. Any questions on this here so far? We good with this here? Okay. Now we just need to find the value of x. We need to distribute. Well, 3 times 4x is 12x. 3 times 5 is plus 15. We can do the same thing to the other side. Distribute the 9. 9 times x is 9x. Plus 9 times 1 is 9. What do we need to do next to solve for the value of x?
I guess you could add 9, or you subtract 9x from both.
Yeah, we can subtract 9x from both sides. We need to get the value of x on the same side, because 9x minus 9x will cancel. 12x minus 9x will give us 3x. Plus 15 is equal to 9. Well, what can we do next? right, we can subtract the 15 because, again, we're still trying to get x by itself. It leaves us with 3x is equal to -6. And last but not least, we divide by 3. And it tells us x is equal to -2.
I know.
And that's it. I mean, as long as it's not one of our restrictions, then we're good. Is -2 one of our restrictions? Or did we list any restrictions? Well, no. Okay, let's go back and look and see. So these two denominators here would be our restrictions. Well, for this here, all right, let's get a, yep. For this here, x cannot be -1 or -5/4. Is what it ends up being, because the x minus 1. Okay. I don't know what that is. -1 or -5/4. Is what we get. So it can't be one of these two values. Because if we solve these here for 0, x plus 1 would be -1, and 4x minus 5, or plus 5 would give us our -5/4. So it's not either one of these values. So finding the restrictions is going to be helpful, because if we solve it and one of our x's is one of the restrictions, it will tell us already that this value doesn't work, but the other one does. Okay. If we're good with that one there, we're going to look at this next one here. So we look at this one here, we want to solve this here. So our 2 over x plus 2 is equal to 10 over 3x plus 2. Yes. Let's do that. Yeah, let's find the restrictions first. Because it's kind of helpful if we know what the restrictions are first. That way, once we get to the solution, we know which ones don't work. So we look at this here. Well, one of them is going to come from our x plus 2. And what value of x can we have for that? -2. Now, we're also going to have a restriction for 3x plus 2. And we can set that equal to 0. 3x plus 2 is equal to 0. Well, we would subtract 2 and get 3x is equal to -2. Divide by 3, and it'll tell us that x cannot be -2/3. So it works out -2 and -2/3 are going to be our restrictions for this here. Any questions on these here? Now, what we're using to simplify these out, and what we used in the first one, is the least common denominator. The least common denominator is a number or set of terms that we multiply everything by so that the fractions simplify, so we don't have any fractions left. Now, looking at this here, what would our least common denominator be? What are we going to multiply both sides by? 3x plus 2. Anything else? And x plus 2. We're going to use both of these here, because we're just using what's on bottom to simplify the fractions out. Now, the only time we're not going to just grab what's on bottom of both of these here is if one of them is factorable. Because if you notice, especially when we did our complex fractions, where if there's a common term in more than one of them, we didn't use it twice. We only needed it once because it only appeared once. We needed it once. We only used it twice as if it appeared twice, okay? So none of these are going to factor, none of the ones that we're going to do today, so we can mainly just grab those. But if it appears more than once, we don't need it more than once. Now let's see what simplifies. Well, on the left-hand side, the x plus 2 and the x plus 2 will cancel. On the right-hand side, the 3x plus 2 and the 3x plus 2 will simplify out. And what that leaves us with is 2 times 3x plus 2 is equal to 10 times x plus 2. And we're left with this here. Any questions on any of this here so far? Do you like this here so far? Okay. Myself a little bit of room. Now we need to solve. Well, the first thing we can do in solving is to distribute these here. Well, 2 times 3x is 6x, plus 2 times 2 is 4. 10 times x will be 10x, and 10 times 2 is 20. So now that we distributed everything, we got rid of the parentheses, our next step would be to do what? What would we do next? We would subtract 6x from both sides, because 6x minus 6x would be 0, so that leaves us with 4, is equal to, well, 10x minus 6x is going to be 4x plus 20, because we're trying to get x up by itself. And after this here, we're going to still try to get x by itself by subtracting 20 from both sides. Too far. And if we subtract 20 from both sides, we do get 4x by itself. 4 minus 20 is going to be negative 16. And what can we do next? We can divide by 4. And if we divide both sides by 4, x is equal to negative 4. Well, is that one of our restrictions? No. So that is the solution for this here. And if we plug it back in to check it, it would work. We would get the same thing on both sides. Any questions on any of this here? Any questions on anything we've done so far today? Okay. Like that. I'm going to try writing that again. I feel like for the most part, y'all are getting the hang of this. Yes, this is not bad. Probably is the easiest thing we've done this chapter besides direct and inverse and neither. Direct variation, inverse variation, and neither. So we'll do this one here, and then we'll move on to the next type, or next thing that we're going to do today. Now, looking at the restrictions for this here aren't that bad. Because what can x not be? 7 or 0. Because we have 5x equals, so here it's just 5x. And if we're solving that, we'd say 5x is equal to 0. So we can divide both sides by 5. which would tell us x is equal to 0. Now, it is tempting to use the 5 since it's with it, but because they're being multiplied together, it's just going to be 0. Because if we don't have anything really added or subtracted or any powers, it's just a variable and a number, most likely it's going to turn out to be 0. And if you're unsure, I would just set them equal to 0 and solve. Because we don't have to do it in our head. We can write it down and make sure. Okay, so that gave us that. Now the least common denominator, what we're going to call the LCD, is what we multiply both sides by. Now what are we going to be multiplying both sides by here? Okay? Yes. And again, we multiply both sides by this so that the denominators will simplify out, so they will cancel out. Now on the left-hand side, the 5x and 5x will simplify. On the right-hand side, the x minus 7 and x minus 7 will simplify out. And what that leaves us with is 3 times x minus 7 is equal to 2 times 5x. And that is what we are left with. Well, we don't have any fractions anymore, so we can go on and simplify this, yes? So let's go on and solve. So we would distribute the 3 here. Well, 3 times x is 3x minus 3 times 7 is 21 is equal to, well, 2 times 5x is 10x. What would we do next? I'd subtract 3x. Adding 21 to both sides wouldn't be wrong, but we would have to move the 10x over. So it'd be a little bit easier to subtract 3x because those will cancel. Minus negative 21 is equal to 7x. At which point we can divide both sides by 7, leaving us with x is equal to negative 3. Is that one of our restrictions? Well, no. So that's the answer. That's it. And we can plug it back in and check, but this is it here. Any questions? Then if it was, it doesn't work. It just wouldn't have it. If all of our solutions don't work or all of them are included in the restrictions, then it doesn't have a solution. Then it's no solution. And it is possible to have no solutions, but we won't really delve into that too much till a little bit later on. Because I want you all to get used to kind of what we're doing with this here first before we start delving into that. And the no solutions and other ones will take a little bit more time. That's why we're going to spend 2 days on it. We'll see. It might take 1 day, but we'll look at it a little bit more closely. I feel like y'all feel good with these here, yes? Okay. Let's look at these. Let's look at these here. x plus 7 over 4 equals negative 9 over x. I don't like that 9. Okay. Now I'm going to write on this here, and we'll move it over here in a second. When I look at the negative 9 over x, what would I need to multiply it by so that the fraction reduces, so we don't have a fraction anymore? What would I need to multiply it by? So what would you need to multiply this fraction by so the fraction goes away?
X.
We need to multiply it by x, yes? Okay, so we're going to multiply both sides by x, yes? Is that going to be part of the LCD, what we're multiplying? I'll need an x, yes? Okay, so how about the 7/4? What would I need to multiply it by so the fraction goes away? A 4, yes? So we'll include that in what we're multiplying everything by, yes? Because that helps out. We got 2 of the fractions done, yes? What about this other one, 5/x? We need an x, yes? So I can add it to the list? So we're going to multiply everything by, no? I actually agree with you. Wouldn't be right. Yes. Because in any one of these 3 spots, x only appears how many times? Once, yes? Since it only appears once, I don't need it twice. I just need it once. I only need it one time because it only appears once. In any of those 3 spots, it only appears once. We would need it twice if one of these wasn't x but was x squared. Because if we had an x squared term, then I would need x squared. So what we can do now, because 4x will simplify these fractions, we're going to multiply each one of them by 4x. So I'm going to multiply this by 4x. So we're going to multiply every term by this here, this 4x. We're multiplying all the way through the equation by 4x. Well, here are the x, and x will cancel. Here the 4 and 4 will cancel. Here the x and x will cancel. And let's see what we're left with. Well, in the first one, we're left with 5 times 4 plus. In the middle one, we're left with 7 times x. And the last one, we're left with negative 9 times 4. So we get this here. Now, if we'd have multiplied by that extra x, what we'd end up getting was 5 times 4x plus 7x squared is equal to negative 9 times 4x. So what we end up getting is an extra value of x. And we'll look at that here in a minute. We're mainly going to look at this one here first. Let's go on and solve this here. Well, actually, yes. I forgot to do the restrictions again, didn't I? So what would the restrictions be here? X cannot equal what? Well, the 4 is by itself. Yes, we don't have a variable with it. So the only places that we have variables are here and here. And since they're by themselves, there's nothing added or subtracted. It can't be 0. Those work out a little bit easier. Because if we want to check it to see if that's it, since they're both the same, well, I can see what value of x, cut them equal to 0, and they would be 0, so it doesn't work. So as long as we don't get x as 0, we will have a solution for this here. Okay? Now, 5 times 4 is going to give us 20. Negative 9 times 4 will be negative 36. Now, to get x by itself, the first thing we can do is subtract 20 from both sides, which will tell us that 7x is equal to negative 56. And last but not least, we can divide both sides by 7, which tells us x is equal to negative 8. Now, is negative 8 one of our solutions? Or one of our restrictions? Well, no, so it works, yes? And that's our answer. Any questions on any of this here? Okay. We're going to do this one here. This will be the last one we do today, and y'all will let y'all go on and get started on the assignment. Now, looking at this here, what are our restrictions going to be? Because let's start off with those. Because we have the x minus 5. 0. Because the x minus 5, if we plug 5 into that there, 5 minus 5 would give us 0. Now, 3 over x, because it's just x in the denominator, it would be 0. So we would have 5 and 0. Now we need to figure out what the least common denominator is. We need to figure out what we're going to multiply each thing by so that the fraction reduces. Well, one thing we see is, well, I have an x minus 5 in the denominator, so we'll need it once. Anything else that we need? Well, the x, because the x and the x minus 5 will be the two things that will simplify this. Now that we can multiply by each one of these fractions and get the denominators to reduce. So I multiply through this here, well, the x minus 5 and x minus 5 will cancel. Here, the x and x will cancel. And that there will reduce our fractions. Any questions on this here? So let's see what happens after we multiply this through. Well, x times x minus 5 times 1 will just be x times x minus 5 minus 8. The x minus 5 and x minus 5 cancel, so that leaves us with negative 8x. Now on our other side, we'll have 3 times x minus 5. Okay, now we just need to solve for the value of x. So the first thing we'll need to do is distribute through these parentheses. So here we're going to distribute the x, so x times x would be x squared. X times negative 5 would be negative 5x. We have minus 8x is equal to, here we're going to have 3 times x would be 3x. 3 times negative 5 would be negative 15. So again, we're just simplifying this here so we can solve for the value of x. Now at this point here, we can combine any like terms, and we do have a pair of like terms. Our pair of like terms are going to be negative 5x minus 8x. And negative 5x minus 8x would be negative 13x is equal to 3x minus 15. Now what can we do at this point here? So we can do either one of those, but we're needing to move everything to the same side because this is a quadratic. As soon as we see that we have a degree higher than 2, most likely we're going to need to get everything on the same side. So because we do have a quadratic, a x squared term, we need to get everything on the same side, and this equal to 0. So in order to do that, we need to subtract 3x from both sides. So subtracting 3x from both sides will cause the 3x to cancel. And that'll give us x squared minus 16x is equal to negative 15. Any questions on any of this here so far? Okay. Well, what we need to do next is, again, we need this equal to 0. So this time we're going to add 15 to both sides, because negative 15 plus 15 will simplify to 0. And on the other side, we're going to get x squared minus 16x plus 15. We have this quadratic here. Now at this point here, we can use the quadratic formula or we can factor it. Either way works. Which way do y'all want to use? We can factor it. And if we factor this here, so two sets of parentheses equals 0. Since 15 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. The factors of x squared would be x and x. And what factors of 15 would we use? 15 and 1. Now, because we have two things multiplied together to equal 0, the only way that I can multiply two things together and equal 0 is if one of these is 0. So either x minus 15 is equal to 0 or x minus 1 is 0. One of them has to be 0. Well, to solve this here, well, I can add 15 to both sides. And it tells me either x is equal to 15 or here we would add 1 to both sides and it would tell me x is equal to 1. Now, either one of these are restrictions. I'm going to look back and see. Well, our restrictions were 5 and 0. We got 15 and 1, so neither one of these are our restrictions. So these two answers are our solutions. So it is possible to have more than one answer as a solution. We have more than one solution. But most likely if we have more than one, we're dealing with a quadratic. And that is it. That is all we're going to be doing today. We will be covering these more